Okay, now we're going to talk about instantaneous velocity, which we already brought up a little bit in our calculus chapter. Recall that the instantaneous velocity, the velocity as a function of time, so any time that we can plug into some function is equal to the limit as t approaches 0 of delta x over delta t, or just the derivative of some function, position function with respect to time. So if I give you the position function, you can take the derivative to find the velocity function. Then we plug in any time in order to find the velocity at any time. Okay? So now somebody's probably saying to themselves, well, shouldn't that be x of t plus h minus x of t? Well, I've already accomplished that because that's delta x up there, my change in position, which is accounting for that small amount of time difference. And also remember that we're squeezing that time difference down. We're making the limit, we're taking the limit as t approaches 0 in order to get our derivative. So a couple of examples. Let's say our first example is equal to x of t is equal to 3t squared plus 4t plus 6. Okay? And we want to find the velocity at t equals 3 seconds. Find the velocity at t equals 3 seconds. Now, you can pause the video right now and do this for yourself. I'm going to continue going here, but this is actually a good example. You should feel confident to do this. The velocity as a function of time is going to be equal to the derivative of the position with respect to time. So go through, find all your t's, take the derivative. 3t squared is going to go to 6t, plus 4t goes to 4, and then 6 is a constant, so that goes to 0. Now we're going to plug in our time of 3 seconds, so the velocity at 3 seconds is equal to 6 times 3 plus 4, and our velocity at 3 seconds is equal to 6 times 3 is 18 plus 4 is 22. So the velocity at 3 seconds is 22 meters per second. Okay? Another example. The position as a function of time is equal to 4t squared minus 12t plus 36. The position is equal to 4t squared minus 12t plus 36. We want to find the position and velocity at t equals 3 seconds. So we want to find both in this case. We want to find the position and the velocity. Again, you can pause the video and actually do this problem if you want some practice. To find the position at 3 seconds, all we need to do is plug the 3 seconds into our top equation. So x at 3 seconds is equal to 4 times 3 squared minus 12 times 3 plus 36. And you see that that's going to be equal to 9 times 4, which is 36. These two 36s cancel out. So we get that the position at 3 seconds is equal to 36 meters. Somebody in the room is probably going, well, shouldn't you put a unit up here on your function? Tell us if it's in inches or miles or kilometers. Let's just assume it's in meters. Let's just assume it's in meters. Most of your problems will be in meters. To get the velocity at 3 seconds, we want to take the derivative of our position function. So the velocity function is equal to the derivative of the position function with respect to time. 4t squared is going to go to 8t minus 12, and then 36 goes to 0. Now put in the velocity at 3 seconds. That's going to be equal to 8 times 3 minus 12. Or the velocity at 3 seconds is equal to 24 minus 12, or 12 meters per second. So we've got our velocity at 3 seconds, and we've got our position at 3 seconds. Now when you're doing problems on a homework or a test, I would actually box your answers, make it real easy for me. Again, treat me like an idiot. Make sure I know what you're doing, and make your work clean and concise. I want to give you guys partial credit, but if you make it tough on me, I'm not going to go looking for answers. I will not. Okay? Last one. Let's say I give you the velocity function. The velocity as a function of time is equal to 3t squared plus 4t plus 6. So I give you the velocity, 3t squared plus 4t plus 6. I want you to find the displacement from t equals 0 to t equals 2 seconds. So I gave you the velocity. I gave you the velocity as a function of time, 3t squared plus 4t plus 6, and I want you to find the displacement from t equals 0 to t equals 2 seconds. I'll let you try that for a sec. Yes, I'm drinking my coffee. Stop laughing. Okay. If you remember the ladder in terms of derivatives, we said that the position, you take the derivative to get the velocity, and then you take the derivative in order to get the acceleration. Since I gave you the velocity as a function of time, and I'm asking you to find the displacement, what I'm really doing is asking you to find the change in position. So we need to work up the ladder. We need to integrate the velocity function, and I've given you the limits of the integration. I've told you that you're going to go from t equals 0 to t equals 2 seconds. Okay? So let's integrate this guy. We're going to integrate from t equals 0 to t equals 2. Our function, in this case, that's 3t squared plus 4t plus 6. We're integrating that with respect to t. Okay? Another chance for us to check our work when it comes to taking derivatives. 3t squared goes to t cubed. If I take the derivative of that, I get back 3t squared, so that guy's good. Now I've got 4t, so that's going to be plus t squared. I need a 2 out front because when I take the derivative of this, the 2 comes down in front and I make 4t right there. And then plus 6t, and we're going to evaluate this from t equals 0 to t equals 2. Remember that we do not need to include the constant plus c because this is a definite integral. This is a definite integral, and when we have a definite integral, the c would just drop out. T equals 0 is going to kill each one of these terms. T equals 2 is going to be the one we're looking for. So that's 2 cubed plus 2 times 2 squared plus 6 times 2. So what's that going to be? 2 cubed is 2 times 2 times 2, which is 8. We have 2 cubed again, which is going to be 16. 16 plus 12 is going to be 28 meters. Very good. I can do math. All right. So our change in position, our displacement, with this velocity function from t equals 0 to t equals 2 seconds is 28 meters. Okay? Hopefully that is pretty straightforward. Hopefully that is pretty straightforward. Okay? Now you guys should be able to put a pretty big hurt on the homework problems right now. You still need to think about acceleration. Again, just think about the ladder, and acceleration being a change in velocity with respect to time. Okay? We're going to talk about that on Tuesday when I get back. But you guys should have some time right now to work on problems. And again, you can watch this lecture series again if you want to learn a little bit more. Okay? Good luck. Have fun.